So Kong API Gateway, which is a cloud native tool, and you can actually utilize it in your infrastructure as a front end for your backend services, which is highly configurable, and actually you can implement many of your requirements using this tool. So like for example, you can implement many methods of authentication, like for example basic authentication, API key authentication, or you can use it as a load balancer that will actually distribute the load among the upstream servers that you define to it, and as a result it can actually provide your service with more high availability. Also, you can implement many security features, like for example you can implement IP restrictions to only give access to the clients with specified IP addresses, or bot detection to actually detect the known harmful bots and actually deny access to them. Also, in order to increase your performance, you can implement caching in this level, so actually the load on your infrastructure will be decreased, and as a result you can actually handle more requests incoming from your clients. And also it can act as the centralized logging system. So basically, whatever the request is received by Kong API Gateway and later be routed to one of your backend servers will actually have its log saved on the Kong API Gateway level. So as a result, you can actually monitor the logs using tools like Elasticsearch and Kibana, and actually you can detect anomalies and many other cool features. So these are all we're going to see in this video, and I've got the timestamps down below so you can skip to the part that you're interested in. So without any delay, let's get down to work. So this is our client apps. We have a application in a microservices architecture, and we have a web interface and a mobile application. So the correct place for the API gateway is between the client and all our microservices, and in a network view, the port of the API gateway only gets exposed to the outside world without exposing each of the microservices ports to the outside. So this is one of the advantages that the API gateway gives for us. So in this picture we have a single point of entry, and if ever we change the IP and port for our microservices, client won't know the change. The only change that we need to make is in our API gateway, so we have to change the configuration for the, so for example, if we need to change the IP for the catalog microservice, the only thing that we need is change the configuration on the API gateway side and define the new IP that gets assigned to the new microservice. So this is one design, and in another design we can have multiple API gateways for multiple interfaces that we have on the client side. For example, for the web application we can have a separate API gateway, another one for mobile application, and another one, for example, if ever our application has some APIs that the third-party applications use. So as we see here, our microservices can handle REST APIs and gRPC connections, and our API gateway should be handling both connections. And also, if ever there are other protocols for connecting to our backends, the API gateway should be handling that and translate the HTTP request that comes from the client to the relevant connection that the exact backend can handle. So this is a total overview of what API gateways are. It has a lot of advantages. Also, it has some disadvantages. For example, we are adding another layer that can cause us a little bit more latency, and maybe another one can be that we have a single point of failure, which will force us to also replicate our API gateways and have multiple API gateways for example, the web application. If one of them gets down by any reason, the others will be handling the requests and gets the responses from the backend services and sends back the data to the client. So of course this has meaning in architectures like microservices or SOAs or other similar architectures, and I recommend before using the API gateway you know about all the advantages and disadvantages that it gives for us. So as I said in the beginning of the video, we are going to focus on the Kong API gateway on this video series, and we are going to deploy it using Docker in a standalone mode, and we are going to deploy it in a DB-less mode, aka declarative mode, and later in the next videos we are going to test out its plugins that it gives for us, which are listed in this web page that I'm going to put the link down in the comments section. So let's not jump ahead of us and first try to deploy this in the Docker environment as a Docker container using a Docker Compose. So if you don't know what Docker is, I'll put the link to my video in which I tried to explain a little bit, and I really recommend you read the documentations in its web page because it is a cool thing to use when deploying the necessary tools. But if you don't know about Docker, I'll try to explain a little bit also in this video, so no worries, let's get into work. So to get started, I recommend you clone my repository in which I'll put all the configurations that we create in this video series and also the other codes and configuration files for other videos that I have in my channel, and I recommend you watch them. So to get started, I am going to create a directory called config, and I'll cd into the config directory, and in here I'll try to create a kong.yaml file which is going to hold the configurations to the Kong gateway. So basically the config file is where we define our upstream servers and plugins that can be applied to a route, to a service, or globally. So no worries, I'll explain all these step by step. So the first thing in here, I'm going to declare my format version. This is common in all YAML files, that declares the version of the YAML file. And the next thing, I am going to start by declaring my services block. So I'll say services, and I'll start to declare my services. So the first service, I'll pass the name, I'll pass the echo server as the value, I'll pass the URL for the service. So I'll say URL is equal to the upstream server's exact IP and port. So the next thing, I am going to need to give this service a route. So I'm going to say route. Again, I am going to pass a name. So I'll say -name. I'll pass echo as the value. Next, I'm going to define the path for the exact service that I'm defining right now. So the next thing, I'm going to define the paths for this service, and I'll pass it /echo as the value for the path. So this is my initial and basic configuration to pass to the Kong gateway. So I'll save my file and I'll exit. If I hit ls, I'll make sure my config file has been created. So I'll cd a directory back, and in here I'll try to create a Docker Compose file. So again, it is a YAML file, and basically in this file we are going to define our services that we want the Docker engine to pull the relevant images and create our services, which in our case is the Kong API gateway. So again, the first thing that I want to declare is the version of this YAML file, and the next I am going to create the services block. The one and only service that I want to have is Kong gateway. So the first thing that I need to say is the image, which will be Kong. Next, I need to mount my config file inside the relevant directory inside the container. So I am going to need to say volumes and pass the config file location as the value inside the containers. So I'll say ./config, and by saying a colon, I'm going to define the location that my config directory should be placed inside the container. So next I'm going to need to pass some environment variables. So I'll copy paste some variables from the official documentations. So for example, the Kong database is off because we are using the declarative mode. The config file location should be exactly the same that we passed our config file inside the container, and some other variables that, as I said, I copied from the official documentations of the Kong in the Docker website. So next we need to define the ports to be interacting with this service from the outside world. So we need to expose some ports to the outside so we can have interactions with the container that is running in the Docker. So I'm going to save my file, and so I'll hit save and exit, and now all I need to do is say docker compose up, and this is going to first pull the image from the Docker Hub registry if I don't have the relevant image, but because I have already pulled the image, it is not going to download the image and use the local image that I downloaded, and because of that this is going to be up and running in seconds. So if it takes a little bit longer for you, just let it do what it has to do. So as we see, I have my Kong gateway up and running and listening on the ports that I defined in the Docker Compose file. So I'm going to access the Kong gateway in my browser. So I'll say localhost 8000, and in here I see that the message that it returns is saying no route matched with the values that I passed to my request. So if I add the /echo at the end, so I'll see that the response is coming from the upstream service, which is the echo server that is running in its own port, and so the Kong gateway successfully goes and grabs the response from the upstream server and shows me as the client whatever the response that the upstream server is returning to the Kong. So first of all, let's have a look of why the course even exists. So here is a simple description of what course stands for. So cross-origin resource sharing, aka course, is an HTTP header based mechanism that allows a server to indicate any origins, domain, scheme or port other than its own from which a browser should permit loading resources. So to understand more here in a schematic way, we can understand more clearly of what course is. So for example, suppose we have a website that loads content from its own origin, which are the same origin requests. So for example, to load a website, it should make some GET requests for some images and for maybe CSS files and any other APIs that a backend service provides. So these are called same origin requests if the domains match exactly the domain that the site has been loaded and the requests that are being sent to the domains of the backend servers. Also, to load the rest of the website, we have some images, some fonts, or maybe again some requests that are being sent to the domain that is not the same as the domain that the website originally gets loaded. So these are called cross-origin requests, and without setting any specified headers, the browser would block the requests and the response wouldn't be coming back to the website. So in order to see how to implement these policies in the Kong API gateway and to understand more, let's get in action and let's get down to work. So in my machine, in a random port, I've run a echo server which echoes whatever request that is being sent to it. And in my Kong config, as we saw in the previous video, I have the service defined in my config file. So if I nano the config file, I'll see that a service has been defined and proxy to the upstream server, which is my echo server. So if I hit docker compose up, and my container gets up and running, and also I see that in the port that the Kong is running, if I make a request to the /echo, I'll see that the exact same response is coming from the backend server. So my basic implementation of the Kong declarative mode is successfully working. And if we see in more details, I'll inspect the request, and in here in the response headers I see that there is no header related to the course policies. So if I go to the Kong official website, and in the section related to the Kong course plugin, I can see that there are some configuration for setting the course plugin to the Kong's config file in the declarative mode. So in here I see how to enable the plugin globally, and if I scroll a little bit below, I'll see that there are all the parameters that I can pass to the plugin, which I'm going to copy the example configuration that is in here. And if I copy, and I'll hit Ctrl+C in here to stop the docker compose service, and if I again nano the config file, and if I paste whatever I just copied from the official documentations, I can see that I have a section where I can define my origins, and here is the place where I can define which origins, which domains can use my contents if they ever make requests to my domain. Also I can see that which methods are allowed to be requested to my domain. Also I can define which headers are allowed. So if I save my file, and again I'll say docker compose up to start my Kong service, and also because I'm not running my Kong on a HTTPS domain, I should be requesting from a HTTP domain so that the browser wouldn't block my requests. So I have found a random domain which is hosted in a HTTP form. So in here I'm going to make some requests to the Kong server, and I'm going to use fetch, and I'm going to copy my Kong's URL and paste over here as the URL for the fetch function. So here I'll hit enter, and I see that here it is blocked by the course policies. So as I said, because our Kong is served on a IP and it is not even HTTPS, the browser is going to block the requests. So I found here in the Chrome flags in the section which says block insecure private network requests. So here if I disable this flag and reload my browser, I'll jump back to the console and make the same request again. So this time I see that it is because of the course policies, and it is blocked because of the allowed origin is not equal as the domain that I'm making the request. So if I go back to my config file, I'll hit Ctrl+C again. I'll try to edit my file, and in here I'll copy the URL of the website that I'm going to allow the requests. I'll paste the URL. So just make sure you remove the last slash from the URL. I'll hit save, and again I'll try to run my Kong. This time if I make a request, I'll see that the response has come from the upstream server, and I get the status code 200, which is okay. And also I'll see here that the access control allow origin is the same as the domain that I'm making the request. So what happened here is that the Kong gateway will give responses only for this domain. So as we see here, if I go back to the config file, the origins key accepts a array value, so I can pass here as many domains as I want. For example, I have 2 different domains that are making requests to the same backend, the same gateway. I can add them over here, but there is a value. If I remove the domain and I pass the star as the value, I'll hit save, and again I'll try to run my Kong gateway, and also this time I'm expecting to get the response from the Kong gateway. So I'll hit enter, and in here again I'll see that the status code for my request is 200 and I get the response from the upstream server. So I hope you get the idea, and as we saw in the parameters that are valid for this plugin, we saw the origins key where we can add our domains that are valid to make requests and share content between domains, and we can pass methods, and the available values can be any one of these. Also, this is an array and it can accept multiple values. Also, we have the section for the headers. We can add any headers that can be valid. For example, if I go to the config file, I can add over here, for example, the authorization header, which can be a valid header to be sent to my Kong gateway. And again, also we have some other options that we can pass to this plugin. We have here the max age, which indicates how long the result of the pre-flight request can be cached. So here we successfully used the course plugin and we enabled it as a global plugin, which will take effect in all our services that we declare in our config file. So we can enable the plugin on a specific route. So in this way we should pass the route key where we define the plugin options, and also we can enable the plugin on a service, and again in this case we should provide the service key where we define our plugin options. So the description that the Wikipedia provides about the rate limiting. So as it says, rate limiting is used to control the rate of the request sent or received by a network interface controller. It can be used to prevent DOS attacks and limit web scraping. So another fact about this research indicates flooding rates for one zombie machine are in excess of 20 HTTP GET requests per second. So that the description that the Kong official documentation says about the rate limiting is that it is how many HTTP requests can be made in a given period of seconds, minutes, hours, days, or even months or years. And if the underlying service has no authentication layer, the client IP will be used. So as it is saying, the plugin will be limiting according to the client's IP address, and it is going to limit how many HTTP requests can be made in a given period of seconds, minutes, hours, days, months, or even years. And it is going to have configurations, and so we'll see it in action. So as we saw in the previous videos, I hope you've been following me along, and I'll be glad if you had any questions, just ask me in the comments section. We have deployed the Kong gateway in a Docker container, and we have successfully configured a route for an echo server that we ran in a random port. And also in the previous video we configured the course plugin so we can make requests to the Kong gateway, and in this video we'll be configuring the rate limit plugin. So let's get down to work. So if I go to my configuration file, I'll hit ls, so I'll hit nano config Kong YAML. In here I see that I have defined a service and I've pointed to the matching route, matching IP port of the upstream server. And here is the configuration of the course plugin. And if you have any questions, I recommend you go watch the previous videos. And in this video, we're going to add the configurations for the rate limit plugin. So I'll go back to the official documentations. I'll scroll down. I'll switch to the declarative tab, and in here we have a simple configuration to enable the plugin on a service. So that's not what I want. I want to enable the plugin globally. So I'll scroll down and I reach the place where I have the simplest configuration for enabling the rate limiting plugin. So in order to make a request, I'm going to first run my Kong gateway. So in here, I'll hit Ctrl X to exit the nano. And here, all I need is say docker compose up. So my Kong gateway is listening on the 8000 port. So if I go make a request here, I see I have successfully got my response. And if I check the response headers section of the request, there are no headers related to the rate limiting. So as it is expected, we have not configured the relevant configurations. And the next thing, I'm going to copy paste the basic configuration and I'll hit Ctrl C. Again, I'll nano my configuration, and in here I'll paste my configuration that I just copied, and I'll remove these plugins. So this is going to rate limit my requests with the maximum of 5 per second. So I'm going to comment this line, and for the hours section, I'm going to leave 10 for now just to test the results. And again, I'm going to say docker compose up, and if I go and refresh my page here in the response headers, I'll see that the rate limit headers have been successfully added to the headers that are coming for the client in the response headers section. And in here, I see that the rate limit is set to 10 because I provide 10 in the configuration. Again, if I hit refresh, in here I see that the rate limiting remaining is the number 8. So again, if I refresh, I'll see the remaining is 7. And also we have a header which is rate limit reset, which is saying when the rate limit will be reset, and the rate limit remaining header will be equal to the rate limit header. So if I again hit refresh as many times so I can reach the rate limit, this time I see that the status of my response is not equal to 200 and it is 429, which stands for too many requests. So with this response, I see that my rate limit plugin is working successfully, and I have successfully configured the rate limit to the configuration in the DBLS mode of the Kong API gateway. So moving down in the official documentations, we have all kinds of parameters that we can pass to the rate limit plugin. So we have second, minute, hour, day, month, year. So whichever we pass to the configuration, depending on our case, depending on our resource that our backends, our services are up in that server, we'll try to write our configurations. And moving up, we have the limit by configuration. So it is an optional configuration, and as it is saying, the entity that will be used when aggregating the limits will be the consumer credentials, IP, service, header, path. And if the value of the entity chosen to aggregate the limit cannot be determined, the system will always fall back to the IP, which is now in my case, so I haven't provided a limit by configuration, so it is limiting my requests based on my IP address. So if I change my IP, or maybe if I try to request from another computer, again I'll have the 10 rate limit as I've configured in the configuration file. So moving down, here we have the policy configuration. Again, it is optional and is local by default. So it is saying the rate limiting policies to use for retrieving and incrementing the limits available values are local, cluster, and Redis. So in local, counters are stored locally in memory on the node, so the other nodes won't be accessing those data, and it'll only be used in a single mode of the Kong deployment. And also, if the Kong service gets down, restarts or stops and starts again, the data will be lost and all the rate limiting data will be reset to 0. Also, we have the cluster policy that counters are stored in a Kong data store and shared across nodes, but this policy is not available in the DBLS mode. And the next is the Redis, that the counters are stored on a Redis server and shared across the nodes also. So as I said, in the DBLS modes, the cluster config policy is not supported, but we are going to see on how to use the Redis and connect our Kong gateway to a Redis database and see it in action, that the data are getting stored in the Redis database. So in order to do this, we need to define the policy in our configuration file. So I'll hit Ctrl C and try to edit my file, and in here I'll try to add the policy config and I'll set it to Redis. And in this case we also need to define the Redis configurations. So if we scroll down here, we have the Redis host, which is exactly the same as my host that my Kong gateway is running on. The next thing is the Redis port, which in my case is the default port, so there is no need to defining it. And the Redis username is in my case the default username. Also, I don't need to define the Redis username. And the Redis password, which in my case is example, and we are set. I'll hit save, and again I'll say docker compose up. So my Kong gateway is up and running. So using Visual Studio Code, using the Redis extension, I've successfully made a connection to my local Redis server that I'm running on my local machine. So again, in here, if I try to refresh, I'll go back to the VS Code, I'll hit refresh, and in here I'll see that the Kong gateway has made a successful connection to my Redis and a key has been added, which in the end includes the IP that the client is making the request and some other data, colon, hour at the end, which in my case is the only configuration that I've passed to the config file. So the number that is stored in here is 1. If I hit refresh, I go back and refresh, I'll see that the number has changed to 2. Again, also, if I hit refresh more and more, I'll see again that the API rate limit exceeded and I get the 429 response, which is too many requests. So again, if I hit refresh, I get the number. I see that the 10 has been stored in the key where my IP is stored. So here we have a client. Our reverse proxy server stands between the client and the server, which is, for example, serving our backend services. So in a normal process, our client would send a request to our reverse proxy server, and in here our reverse proxy will check if the IP address is permitted. If yes, it will route the request to the upstream server, and the server would return the response for the client. And if the IP address is in the restriction list, the reverse proxy will return some status, for example 403, which is the status code for the forbidden access. So if we go to the official documentations of Kong for the IP restriction plugin, as it is saying, this will restrict access to a service or a route by either allowing or denying IP addresses. We can both provide single IP addresses and multiple IP addresses or ranges, again to allow or deny access. So again, in a random port, I have a echo server which echoes whatever request that I make, and if I jump to my terminal, I'll hit ls, I'll cd into place where I have my Kong files. In here we have our docker compose file and config file. So if I nano config Kong YAML, which is the config file that I've passed inside the container for the dbless mode of Kong deployment. So in here, in the services section, I have a echo server which is proxy to the upstream server, which is our echo server, and it has the path of /echo. So as you can see, we have our plugins section, and in here we have our course plugin enabled and our rate limiting, which you'd know about if you have been following me along, and if you don't, I recommend you watch my previous videos in this video series, because these are cool stuff to know and they will be handy for your services that you expose to the outside world. So I'll jump back to the official documentations and I'll try to find the sample configuration to enable the plugin globally, and in here I have the simplest configuration, and I'll just go ahead and copy. I'll paste it in my plugins sections of configuration file. So I don't know these IPs, and also I don't know my own IP. I'll hit save, so that the thing that will happen is that the Kong API gateway will only allow access to this exact IP and also to this IP range, which is in class C. So it'll give access to 143.100 up to the 143.10255. So this is how we can define IP ranges for the IP restriction plugin. So I'll hit save, I'll hit Control X, and as you know, all I need to say is docker compose up. So this will run my Kong API gateway in the defined port in the docker compose file, and if I go check my browser, I'll hit refresh, and as I see, this is a Kong error, and as the message is saying, my IP address is not allowed, because the Kong gateway will only give access to the sample IPs that I just copied from the official documentation. So if I go back to my terminal, in here I should see that my IP has been logged to the output of the Docker Compose service, and I'll just copy the IP and I'll hit Control C. Again, I'll try to edit my config file, and in here I'll just paste the IP that I just copied, and also let me just remove the IPs that I just copied from the documentation. So I'll hit Control S to save my file, again Control X, and again I'll say Docker Compose up. I'll go back to my browser, I'll hit refresh, and as you can see, now I have the access to the upstream servers, and also my IP is allowed. So let's go back to the documentations. The allowed parameters that this plugin can handle are as shown in here. So as you saw in the config file, we have allow, which is a list of IPs or ranges to allow, and also we have a deny config, which again is a list of IPs or ranges to deny. Just remember, one of the allow or deny must be specified in the config file. So to test out the deny config, I'll go back to the config file. This time, instead of saying allow, I'll say deny. I'll hit docker compose up. So the thing that should happen is that my IP is restricted and I don't have the access to the upstream servers. So in this configuration, all the IPs are allowed except for my own IP, so everyone can access the upstream servers except for me. So in here we saw how the deny config works. I'll go back to the config file, and in here if I change this last 1 to 0 and I'll say /24 at the end, so I am now allowing a range of IPs which starts from 172.286.4.0 up to the 172.286.4.255. So I'll hit save, I'll exit my file, and if I go check the browser, I should be able to access the upstream server. So as you see, this is how to define IP ranges to allow access to the upstream servers. So going back to the documentations, we have two more configurations that we can pass to this plugin, which is status, which is the HTTP status of the request that will be rejected by the plugin, and it's by default 403, which we saw when we had restricted access to the servers, and the message to be sent back to the client when its IP is restricted, and by default is your IP address is not allowed. So in order to see how this works, I'll go back to the config file, and in here I'll add the status and I'll pass 401 and another one for the message. I'll pass cannot grant access. So again, I'll try to change the allow to deny, and now I can test out the status code and message that the Kong gateway returns when it restricts IPs. So I'll hit docker compose up and again try to access the echo server, and in here I see again a Kong error, and it is exactly the same message that I provided in the config files. And also if I try to inspect the request, in here I see that the status is 401 and it is successfully overwritten the default value, which was 403. So as you know, we have robots that crawl our websites and grab the data that they need and use them for their own purposes. Like for example, we have Google robots that crawl our websites and grab all the data that they need, and for example in its search engine, if anyone search for a content relevant to whatever we have in our websites, Google will recommend our websites based on the data that their robots have grabbed from our websites. So this is the good part of robots and crawling websites, but also we have bad robots that may harm our websites, that may try to attack our services, and many other attacks that they will be able to make using those robots. And for this reason, we should be able to allow the robots that we know and we trust and deny access for those we don't. So as it is saying in the Kong documentations, this plugin protects a service or a route from most common bots and has the capability of allowing or denying custom clients. So again, we'll try to use this plugin in our declarative mode in the config file that we pass inside the Kong container, and as always I have an echo server that is running in a random port and echoes whatever requests that I make. And also I've defined this service as an upstream service in my Kong configuration. So the thing that I need to know, I'll try to scroll to where I can enable the plugin globally, and here I'll try to copy this simple configuration, and the next thing I'll switch to my terminal. Here I'll hit ls. Here I have my docker compose file and my config directory, which is holding my configuration file, and if I nano the Docker Compose file. In here I see that I have the simple deployment of Kong gateway and the database mode is off, and I've passed the config file inside the ./config directory inside the container as the declarative configuration. The next thing, I'll try to edit the configuration file, and in here I see that I have the configuration for the previous plugins that we used in this video series. So if you haven't watched them, I'll recommend you go watch the previous videos. So in here I have my echo server defined as a service in my config file, and it has the path of /echo. So first of all, I'll try to run my container by hitting Docker Compose up just to test out my Kong gateway has a successful connection to my upstream server. And if I hit refresh in my localhost /echo, I'll see that the Kong gateway has made a successful connection to the echo server and echoed whatever request I made to it. So I'll go back to the config file, and in the plugins section I'll try to paste the basic configuration that I just copied from the documentation. And in here, if I go back to the official documentations, I'll see all the parameters that is available for me to use in this plugin. So the service and the route is the ID of the service or a specific route to define if I wanted to enable this plugin for a specific route or a specific service. So I'll ignore them for now, and in here I see that the allow and deny for this plugin. So allow and deny is an array of regular expressions that should be allowed. The regular expressions will be checked against the user agent header. So this is a key point to notice. And as we get the idea from here, the bot detection works with the user agent header that are being sent from the clients to the servers. So if I go to my echo server, in here I'll try to search for the user agent, and in here I see that the user agent is a value that includes web browsers including Chrome with the version that I have installed. So as we saw in the documentations, the bot detection plugin will try to detect the robots using this header. Pretty fair. I think this is a good way to detect bots because a robot won't be sending the requests from a web browsers, and maybe, for example, try to access our APIs or maybe curl our services using a script file or many other ways that might be out of scope of this video. So because I am making the requests from a Chrome web browser, and just to test out this plugin is working correctly, I'll go back to the config file, and in here, as we saw in the documentations, I'll try to add the deny configuration, and because it is an array, I'll give my values as a list. So in the first record, I'll say Chrome, but because this is a regular expression, I want to deny access for both lower and uppercase. So inside the parentheses, I'll say uppercase C or lowercase c and the rest of the Chrome word. So the bot detection plugin should be denying all the requests that has the Chrome value in their user agent headers. So I'll hit save. Again, I'll say Docker Compose up, and I'll go back to the browser, and if I hit refresh here, I see that I get the error and my access for this service is forbidden. So using this plugin, we can allow robots that has known user agent headers and deny all other robots from accessing our services. So if I scroll down in the documentations, the plugin already includes a basic list of rules that will be checked on every request. So if we go to the URL, in here we see that by default there are some regular expressions, each one for a known robot. For example, one for the Facebook robots, one for Google Plus, for Twitter, or any other robots that will be able to crawl our services. Again, also if you want to deny access for any of these robots, you can just copy and paste in the deny section of the bot detection plugin. And also here I have the top 10 most popular web crawlers and user agents. I'll put the link for this page, and as you see here we have the user agent header values for the most known robots, like for example the Google bot and also the Bing bot and many other robots that are known and trusted by most of the websites. So if you have come this far, I hope you have a basic understanding of what bot detection is, and if I switch to the terminal, I'll copy the address, and in here if I say curl and paste the URL, here I'll see that I should get the response from the upstream server, and the Kong gateway will allow access because my user agent is now curl and not Chrome. So I'm now trying to show you a trick to bypass this bot detection method by trying to change our user agent header's value. So if I switch back to my configuration file and I'll try to add another record for my deny config, and if I say curl in here and I'll hit save, and again I'll say docker compose up, and if I go back and say again curl the URL, here again as you see I get the message of forbidden, and the plugin is denying my access because my user agent is curl and it is in the blacklist of the bot detection plugin. So a way to bypass this, as I said, is by changing the user agent header, and to test out this I'll say curl-h to set a header, and for the user agent I'll pass a value to change my user agent header, and maybe I should be able to get response from the upstream server and bypass the bot detection plugin. So for the value of the user agent header, I'll try to set, for example, postman, and next I'll say my URL for the Kong gateway. So if I hit enter here, as you see I get the response from the upstream server, and I've successfully bypassed the bot detection plugin. So of course there are more ways to also deny access for these kind of bypassings. This is just a simple way, and if you want me to go deeper in this, just go ahead and comment in the comment section. So this is a way to change the user agent for the curl in the terminal. And what if we needed to change our user agent in a web browser? So as you see here, my access to the upstream server is being denied using the Chrome browser, and if I be able to change my user agent header in my requests, I'll be able to access the upstream server and bypass the bot detection plugin. So if I hit refresh in here and go to the request headers, in here I see that the user agent is set to this value by default by the browser, and because it includes the Chrome in it, the bot detection plugin is denying my access to upstream server. So for this problem here I have installed an extension by the name of requestly, which intercepts our requests in browsers and make the necessary changes that we define to it. So by default it has this UI, and here by hitting create my first rule, in here I have the modify headers section and also the user agent. By using both I can change my user agent value and bypass the plugin. So for example I'll use the user agent, and in here I'll try to give my role a name. So I'll just type name in here, for example, and here I'll select the browser, and for example I'll set it to Internet Explorer, and now I can create my role. So my role successfully created, and I'll switch back and hit refresh, and as you see I have now access to the server. So if I inspect my request, here I see that the user agent has been changed to the Windows Explorer, and it doesn't include any Chrome word in it, and because of that I now can access the upstream server. So in a total overview, as you see in here, as always we have some clients and our backend services which are serving our application, maybe some API providers, maybe some servers that are serving static HTML files or whatever, and here we have our API gateway in the middle of the client and our backend services. So the thing that this plugin does is when a client makes a request to our backend services with known URLs, our API gateway will check if it has the relevant response for the specific request, and if it does, it won't make a request to the upstream servers, and it will return the response for that specific request because it has cached the exact same response and it didn't need to make the call for the upstream servers. So this is a total overview, and also it has its own challenges, like for example we have some data in our backend services and we have its copy in our API gateway, and in this moment a client tries to make a change in the backend service and API gateway doesn't know about that, and another client tries to get those data and the API gateway will check the request and see it has the data and returns the data that it has without the changes that the other client had made to the main data that is stored in those services. So this is one of the challenges that comes with caching. Also, caching has many other challenges and many other disadvantages. I hope you read all about these before you try to use this plugin, and because of this reason we always try to cache those data that are not changed at all or they are changed in a long period of time. So going to the official documentation of Kong API Gateway, here it says that this plugin provides a reverse proxy cache implementation for Kong. It caches response entities based on a configuration response code and content types, as well as the request method. It can cache per consumer or per API, and cache entities are stored for a configurable period of time, after which subsequent requests to the same response will refetch and restore the resource. Cache entities can also be forcefully purged via the admin API prior to their expiration time. So this is a summary of what this plugin does. Moving down, here we have the basic configuration to enable the plugin globally. So I'll try to copy this. I'll move to my terminal here. If you have cloned my repo, you'll have all these files, which I'll put the links down below. So I'll hit ls. I have my config file in this config directory. So I'll say nano config kong.yaml. So I'll try to paste the configuration in its relevant place in the plugins section. I'll remove the extra plugins, and here I'll try to save the file, and here we see that the response code will be 200, which is okay, and the request method will be get and head. The content types that will be cached will be text plain and application JSON, and the cache TTL will be 300 seconds, and the strategy will be memory. So if we move to the official documentation, here we have the available parameters that we can pass to this plugin. So here we have response code, which by default are 200, 301, 404, and the request method, which is also by default get and head, because it is only logical to cache the get requests, because if we cache post requests, the request won't be reached to the servers, and maybe if we wanted to save a specific data, it won't be saved in the database. So the content type, which is by default text plain and application JSON, the point in here is that if our content type headers value is application JSON with char set of UTF-8, it will be bypassed and won't be reading the data from the cache. So we have other parameters. Here we have cache TTL, which is by default 300 seconds. We have the cache control, which is a boolean, and when it's enabled, it'll respect the cache control behaviors defined in this URL, which I'll put the link down below. We have the storage TTL, which is the number of seconds to keep resources in the storage backend. This value is independent of cache TTL or resource TTLs defined by cache control behaviors. And we have the strategy, which is the backing data store in which to hold cache entities. The only accepted value is memory. So I'll go back to the configuration. I'll save the file. I'll exit, and here I'll say docker compose up. So my Kong gateway will run, and as always I have an echo server in a random port and a route with /echo pointed to that service. So if I refresh here, I'll see that the response is coming from the upstream server, and in another terminal I'll try to access the echo server's logs. So I'll say docker logs -f for following the logs, and I'll say node proxy echo server, and in here I'll see all the logs for the upstream server. So here if I hit refresh, I'll see that the response has been logged to the output. So this shows that the Kong has made a request to the echo server. So this is because if we come here in the inspect section and in the content type section, we have the application JSON with char set of UTF-8. So here I'll try to copy this. This is why the Kong plugin is not caching our requests, because the content types that are defined in the configuration does not match this content type. So I'll go back to the configuration file. In here I'll paste whatever I just copied. I'll hit save, I'll exit, and again I'll try to run my Kong gateway. I'll hit refresh in here. If I go to the logs of my upstream server, again I'll hit refresh, and this time I see that there is nothing logged to the output. So this shows that the plugin is working successfully. And again, if I change my request, for example, I'll pass a random parameter, I go back to the logs of the echo server, again I see that the request has been sent to the upstream server because Kong didn't have the response cached for this exact same request. Again, if I refresh, I'll see that there is nothing logged to the output of the echo server. So another point I want to show here is that the headers that the Kong sends, if it caches the data, so here we have the cache key that is stored in the Kong gateway and the cache status, which is hit. So we have multiple statuses available for this header. If we scroll down in here in the relevant section, we have the cache status section. We have the values miss, hit, refresh, bypass. For miss, the request could not be satisfied in the cache, but an entry for the resource was not found in the cache and the request was proxied upstream. For the heat, the request was satisfied and served from the cache. The refresh, the resource was found in cache but could not satisfy the request due to cache control behaviors or reaching its hard-coded cache TTL threshold. For the bypass, the request could not be satisfied from the cache based on a plugin configuration. So these are all the statuses for the cache status header, and for this case it is a hit. If I change the parameter, it should not be hit. So the cache status is missed because it was not satisfied in the Kong plugin. So as I said, there are disadvantages and there are problems for using this plugin and caching data. So as we saw, I am now getting the response from the proxy cache plugin. So I'll go back to the terminal and I'll hit Ctrl+C. I'll try to stop my echo server. So I'll say docker stop. I'll provide the name. So my upstream server, which is my echo server, is now stopped. And if I try to call it straight, I'll see that there is no response. But if I try to call it from the Kong gateway, I see that I get the responses successfully. And here I get the Kong rate limit exceeded error because I exceeded my rate limit. So next time I'll try to remember to increase the number for the rate limit plugin. So if I switch to my terminal, I'll hit ls. In here I have my docker compose and config file. So if I nano config, I see that I have a simple route defined to the echo server that I have running in my machine. So in the last video we saw how to use the proxy cache plugin and how it works and about its challenges. So if you haven't watched them, I recommend you go watch them because these are some cool tools to know and to use. Moving to the official documentation about the basic authentication plugin. So as it is saying, this plugin will add basic authentication to a service or a route with username and password protection. The plugin checks for valid credentials in the proxy authorization and authorization headers. And if I scroll down in the section that says enable the plugin globally, I'll switch to the declarative tab, and in here I'll try to copy the simple configuration. So if I switch back to my terminal, I'll paste the configuration here. I'll remove the plugins. So moving forward in the documentation, we have the available parameters that are available for this plugin, and in here we have the hide credentials. So it is an optional boolean value telling the plugin to show or hide the credential from the upstream service. So these are all the parameters that are available for this plugin, but this plugin will not work without any consumers. So moving forward, here we have the documentation on how to create a consumer. So what is a consumer? As we see in the documentation, the consumer object represents a consumer or a user of a service. So I'll put the link if you want to read more about this. And moving back to the documentation, I'll switch to the without a database tab. So apparently each consumer has a username and also it can have a custom ID. If we don't pass the ID, it will auto-generate the ID for the specific consumer. So I'll try to copy the configuration about the consumer. I'll switch back to the terminal, and in the configuration file, I'll paste the consumer data that I just copied. So in here, I'll try to define a username. So I'll say user. It can be whatever name that you want. So switching back to the documentation, moving forward, here we see how to create a credential specific to the basic authentication plugin. So here I'll copy the configuration. I'll go back to the terminal, and in here I'll paste the configuration, and I'll try to change the consumer to the user that I just created in the above. So as we can see here, I define a username and a password. So this is the credential related to the consumer with the name of user. So as it said in the description section of this plugin will check the authorization header. So the authorization header must be base64 encoded. For example, in our case, the username colon the password, which will be this value after encoding base64. So I'll go back to the configuration file. I'll try to save the file. In here, all I need is say docker compose up. So my Kong plugin will run successfully. If I go back and make a request, so this will require a username and a password. So I'll try to pass whatever username and password I defined for the consumer. So I'll say sign in, and in here I see the response is coming from the upstream service. So if I inspect the request that is being sent in the headers section, I see that the authorization header is the basic and the base64 of my username and password. So if I want to make a request using curl, I'll switch to the terminal, and in here I'll try to make a curl request passing the authorization header with the exact same value in the Chrome. So if I hit enter, I see that the response is coming successfully from the Kong gateway. But also if I remove the authorization header and try to make a request simply, the data that will be returned from the Kong will be unauthorized. Also using the postman, if I try to make a request without the authorization header, the unauthorized response will be returned from the Kong gateway. And also if I add the authorization header and make another request, I see that the response is coming from the server. So this is how to implement the basic authorization using the Kong API Gateway plugin. And moving next, we'll try to implement the key authentication plugin. So as it is saying, this plugin will add key authentication, also sometimes referred to as an API key, to a service or a route. Consumers then add their API key either in a query string parameter, a header, or a request body to authenticate their requests. So again, I'll scroll down to enable the plugin globally. I'll try to copy the basic configuration. I'll hit Ctrl C to stop the Docker Compose. And again, I'll try to nano the configuration file. And here in the plugin section, I'll paste the configuration that I just copied. So the key names is an array of strings which the plugin will check for the API keys. So by default it is API key, and I'll let it be as it is. Also we have the key in body set to false, so this plugin will not check the body data. Key in header is true, so if I send a header with the name of API key, the plugin will also check. And key in query is set to true. Also the plugin will check the query parameters that are sent on the request. So again, in this plugin we have the hide credentials, which does exactly the same functionality as the basic authentication, and the run on pre-flight, which is set to true, which configures the plugin to check also the options requests coming to the Kong gateway. So moving back to the documentation, moving forward, here again we see how to create a consumer. So we already have a consumer, so I'll scroll down, and here we see how to create an API key. So I'll copy the configuration, I'll move back to the terminal, and in the section below the basic authentication, I'll paste the configuration and I'll change the consumer to user. And also we have the key, which is the valid value for the API key of this consumer. So for example, I'll pass ABC as the value, and also we have the TTL, which is the number of seconds the key is going to be valid. If missing, the TTL is unlimited. So I won't be passing the TTL configuration, and I'll try to save the configuration file, and I'll hit Control X to exit. Again, I'll say docker compose up. So if I move to the Postman, again, I'll try to make a request. This time the error that is coming back is saying no API key found in the request. So I can pass it both in the headers section or the query parameters. So I'll say API key, exactly the same as I defined in the configuration file. And as the value, I'll pass ABC. Again, I'll try to make another request. I see that the response is coming. So if I pass a wrong value for the API key, I'll hit send, and again, I'll see that an error is coming back from the Kong API key plugin. Also, if I try to make a request with a URL parameter saying API key is equal to ABC, I'll hit send. Again, I'll see that the plugin is checking the query parameters of the requests. So that is how to implement an API key authentication using Kong API Gateway plugins. And the next plugin, we are going to see how to use the ACL plugin, which will restrict access to a service or a route by adding consumers to allow or denied list using arbitrary ACL groups. Just notice that this plugin requires an authentication plugin such as basic authentication, key authentication, and other authentication plugins that are available in the Kong API Gateway. So again, I'll try to scroll down where I can enable the plugin globally, and here I'll try to copy the basic configuration. I'll switch back to the terminal. I'll try to nano the config file, and in the plugins section I'll paste the configuration for the ACL plugin. So if I go back to the documentation, I see the available parameters for this plugin. We have the allow and deny, which are the group names of the consumers that will be allowed or denied access for the upstream servers. So how to create groups, I'll scroll down, and in here in the without a database tab, I'll try to copy the configuration of the ACL plugin. So I'll paste the configuration in here. I'll change the name of the consumer to user, and I'll leave the name as the group one. I can change it to whatever I want. So to test out that this is working correctly, I'll try to change the allow to deny. So this will deny the access for my consumer. I'll hit save. Again, I'll try to run the Kong gateway. I'll move back to the Postman. I'll hit send, and in here I see the message coming from the ACL plugin, which is saying you cannot consume this service. So again, I'll try to change the deny to allow. I'll hit docker compose up, and if I make a request, this time I'll see that the response is coming back from the upstream server. So as always, I have my echo server running in a random port, and if you have cloned my repository, which I'll put the link down below, you'll have all the code and all the configuration for running these services. So switching to my terminal, if I hit ls, in here I see that I have my docker compose file for Kong gateway and my config directory, which holds my configuration file for the declarative mode of the Kong gateway. So if I nano the config the Kong YAML file, which I'll pass into the container of Kong API Gateway. As we can see in the previous videos, we configured and used many handy tools, many handy plugins of Kong API Gateway, and also we saw how to define consumers and allow or deny access for each of the consumers. So if I switch to the official documentations in the request termination plugin, as it is saying, this plugin terminates incoming requests with a specified status code and message. This allows to temporarily stop traffic on a service or a route, or even block a consumer. So if I move down in the global plugin configuration section, if I switch to the declarative tab, I see the basic configuration to enable this plugin. So I'm just gonna copy the configuration and switch back to the configuration file. In the plugins section, I'll paste the configuration, and as now I'll expect all the requests for all these services will be blocked with the status code of 403 and the message that I've passed for the message configuration for this plugin. So if I save my file, I'll hit Ctrl X to exit nano, and in here if I say docker compose up, this will run my Kong gateway in Docker container. And if I go to the Postman, I'll try to make a request, and if I hit send, in here I see that the status code for my request is 403 and the message is exactly the same that I passed in the configuration. So going back to the documentation, here we see all the parameters that are available for this plugin, and as we saw, we can pass the status code that the response will have and the message, and also we have some other configuration which is body, which is the raw response body to send. This is mutually exclusive with the config.message field, so either we pass the body or the message configuration to the plugin. So I'll move back to the terminal. In here I'll hit Ctrl C to stop the Docker compose, and again I'll try to edit my config file, and in here I'll comment the message configuration and I'll pass the body, which for example will be a text in a JSON format. So I'll pass A equal to B, and also I'll try to set the content type to the application JSON, and if I hit save, I'll hit Ctrl X and Docker compose up again. Going back to the Postman, I'll hit send, and in here I see that I get the response that I just passed in the configuration. So if I check the headers section for the content type, I get the application JSON that I passed in the configuration. So as the last parameters of this plugin, here we have the trigger configuration. So when we do not set this configuration, the plugin will be always activated, and when set to a string, the plugin will activate exclusively on requests containing either a header or a query parameter that is named the string. So for example, if I want to block all the requests including a queue, which for example will be the search query for my APIs, I will pass the queue as the value for this configuration. So moving back to the terminal, I'll try to edit the file again, and in here I'll pass the trigger, I'll pass queue as the value, I'll save my file. Again, I'll say docker compose up. This time if I make a request, I'll see that I get the response from the upstream server, but if I have a queue string in my query parameters, for example, I'll search for the Kong. If I hit send, this time I see that the plugin is blocking my requests. So this is how this plugin works for blocking requests, maybe temporarily for some services, for maybe routes or globally, and after, for example, the maintenance has been done, we can disable this plugin and all the requests will be proxy to the upstream servers. So the next plugin that we'll be testing is the request size limiting, which, as it is saying, will block incoming requests whose body is greater than a specific size in megabytes. So as a note, for security reasons, we suggest enabling this plugin for any service you add to Kong gateway to prevent a DOS, aka denial of service attack. So as I said, these are really cool tools to use, and any web application in a production level will surely need these plugins to be enabled. So if I move down to the section where I can enable this plugin globally, I have the basic configuration. I'll just copy the configuration. I'll switch to the terminal. I'll hit Ctrl C. Again, I'll try to edit my configuration file, and in here the first thing that I'll do is disable the request termination plugin. So I'll say enabled, set to false, so this won't be blocking my requests, and I'll try to pass the configuration for the request size limiting plugin, and in here for the basic configuration, this will block the requests which have the size greater than 128 megabytes. So I'll try to reduce this value just to be able to show you guys. So I'll pass 1 as the value for the size, and for the unit I'll say kilobytes. So I'll save my file, I'll exit, I'll say docker compose up. If I move to the postman, I'll make a request just to be sure that the request termination plugin is disabled. So for the body, I'll try to pass some value just to make the size greater than 1 kilobytes. So if I make a request, it is most probably not greater than 1 kilobyte. So I'll try to paste more. And again, I'll hit send, and this time I see that the request size limit exceeded is coming back from the Kong gateway, and the status for the request is 413, which stands for request entity too large. So if I go to the official documentation, the available parameters for this plugin, we saw these configurations, and the last configuration, which is the require content length. So as it is saying, we should set to true to ensure a valid content length header exists before reading the request body. So this plugin will append the request and response data in a JSON format to a log file. So as a note, this plugin uses blocking I/O, which could affect performance when writing to physical files on slow disks. So just remember to keep that in mind and do your configuration depending on your resources. So as always, I'll move down to find the configuration to enable the plugin globally. So here we have the sample plugin configuration. So if I move a little bit down, I can see the available parameters that I can pass to this plugin. As always, we have the service, the route, the consumer, and I'll skip them so because I want to enable the plugin globally. Here we have the path, which is the path of the output file. The plugin creates the log file if it doesn't exist, so just keep that in mind. And the thing that is important, make sure the Kong has write permission to that file. If ever the Kong does not have any permission to write to that file, it will skip that, so we wouldn't be having the logs outputted to the file. So we have the reopen configuration, which determines whether the log file is closed and reopened on every request. If the file is not reopened and has been removed, the plugin keeps writing to stale file descriptor and hence loses information. So both setting this to true and false has their own pros and cons. Like for example, if we set this to false, which will not reopen the file, we will have better performance, but also will have this problem. And if we set this to true, we'll surely have performance issues, will have a lot more latency. So depending on your resources, depending on your situation, you can choose to set this to true or false. And also we have a custom fields by Lua. So as we know, the core of the Kong API gateway is written in Lua language, and using this configuration, which is an optional configuration, we can set custom fields if we don't have it by default in the default logging system. It might have its own uses, its own specific uses, so we won't be dealing with that in this video. So I'll just go ahead and copy the sample configuration, and as always I have an echo server running on my machine on a random port, so whatever request I make to it, it'll just go ahead and echo it back to me. So moving to the configuration, in here I have my configuration file which I passed to the Kong gateway as the declarative mode deployed as a Docker container, and in here I have my Docker compose file which I have my configuration to set up and run my Kong gateway. So I'll put the link to my repository down below so you can access all these files. Actually, these are all files for all my videos in here. So the first thing I'm going to do is I'll move to the configuration file. In here in the plugins section, I'm going to paste the configuration that I just copied. I'm going to remove the /temp from here, so the file will be created at the root path. So I'll save my file. I'll switch to the terminal. In here I'll hit ls. I'll see that I am in the exact same directory that I have my configuration and Docker compose file. So all I need, as you know, I have to say docker compose up -d. So I'll pass the -d to run it in a detached mode, so I will be able to do things after that. So I'll hit ls, I'll hit docker exec -it, I'll provide my container name, and I'll have a bash at the end. So I am inside the container which is running the Kong gateway. So if I hit ls, in here I see that there are no files, so I'll move to the Chrome. I'll try to make a request, so the response is coming back from the echo server that I'm running in my machine. So I'll move back. In here I'll hit ls again. So as we can see, it cannot create the file because it has no write permission to it. So because I'm running my container as a root user, and inside the container we have the Kong user, and it cannot create that file because it does not have enough access. So the thing that I'm going to do is I'll exit the container execution. In here I'll hit ls. I'll try to make a directory called logs. I'll cd into the logs directory. In here I'll say touch file.log. In here I see that I have my file which is going to be mounted inside the container, so the logs will be outputted to this file. So if I hit ls-la, so in here I see that my file only has write access for the owner. So if I mount this file inside the container, again the Kong gateway won't be able to write to it. So to test that, I'm going to switch to the Docker compose file. In here I'll add another entry to the volumes. So I'll say ./logs/file.log. I'll mount it to the /file.log. So I'll save my file. I'll try to say docker compose up again. So it is recreating the Kong gateway. Again, I'll switch to the Chrome. I'll hit refresh. In the logs, I should see that the Kong does not have enough permission to write to the log file. And also this time I'll hit Ctrl Z. I'll try to exec the container again, and this time if I hit ls, in here I see that I have the file log in the root path. But again we have the exact same problem, the exact same permission problem. So I'll exit the container, I'll hit ls, I'll say chmod 777, and I'll say file.log. If I hit ls-la, this time I see that the owner and the group and the other users has the access to also write, read, and execute this file. So this is not really a critical file. It's no problem to do this, but depending on your situation, you can manipulate the chmod number. So this time I'll say docker compose down to remove my Docker container. Again, I'll say docker compose up -d. So my container is running. I'll hit ls. I have my file.log in here, and also inside this directory I can open the same file.log which is over here, and if I move to the Chrome, I'll hit refresh. This time I see that the log has been outputted and successfully written to this file. So this plugin is working correctly. If I make more requests, I'll see that the logs are being appended to this file. And also if I check the Docker logs for the Kong gateway, this time I won't be seeing the permission denied error, and as a result I can see the logs are being written to the log file. So as we can see in the official documentations, the HTTP log plugin sends requests and response log to an HTTP server. So it is clear the way that it works, because it sends whatever data that comes to the gateway to an endpoint that gets the Kong gateway's log data and do the thing that it requires, and like for example it saves it in a database or whatever. So as always in the official documentations, I'm going to move down to the place that I can find to enable the plugin globally. In here we have the sample plugin configuration, and in here we have the available parameters that we can use to configure this plugin to the Kong API gateway. So as always we have the name, the service, the route, the consumer, and enabled, which is a boolean. So in here the first parameter that we're going to use is the HTTP endpoint, which is the HTTP URL endpoint to which the data is sent, and the next is the method. So it is the method that is used to send the data over the HTTP request. The supported values are post, which is by default is set to the plugin, and put, and the other one is patch. So this is basically the method that we're going to grab the data on the HTTP endpoint. So we have the content type, which is an optional configuration. Again, the only value can be application JSON, which is the value that is set by default. So the next one is the timeout, an optional timeout in milliseconds when sending the data to the upstream server. So another one is keep alive, which is again an optional value in milliseconds that defines how long an idle connection will live before being closed. So we have also flush timeout, which is also optional time in seconds. In this video we're not going to use it. The retry count, the number of times to retry when sending the data to the upstream server, and the queue size, which is the maximum number of log entries to be sent on each message to the upstream server, and the headers configuration is that when we want to add some headers to the request that is being sent to the upstream servers. So in here we have the log format. As in the previous video, we saw how the log plugin logged the data, which was in the exact same format as in here. So basically this is the format that the HTTP log plugin will send the data to the upstream server. which is the server that is listening to our logs. So that's it. We're going to copy paste the sample configuration to our config file. So in here I'll try to copy the configuration. In here I'll come to the conf.yaml. In the plugins section I'll paste the configuration. So I have a simple Node.js server running in a port which is listening to requests and logs out the request body data. I'm going to run it in a port, so I'll include these in my repository files where I'm going to put the links in the comments section. So basically what it does is exactly as I said, which is a simple Node.js server which is listening to requests and logs out the request data. So as we saw, it is listening on the port 8080. If I go to Chrome, I'll try to make a request. I see that the response is coming from the Node.js server, which is running in the port 8080. And another one, I have my echo server also running in a random port. So going back to the configuration file, I'm going to copy my Node server's address to the HTTP endpoint configuration, and the method will remain post. The timeout will be 1000 milliseconds. The keep alive will also remain the same, and the retry counts is 15 and flush timeout is 2. So this is the configuration to enable the plugin globally to all the requests. So I'm going to save my file, switch to the terminal. All I need is say docker compose up. So this is going to run my Kong API gateway. So whatever request that I make to the Kong API gateway, it is going to make another request to the Node.js server that is running in this terminal, and it'll try to log all the data has been sent to it. So if I switch to Postman, in here I'm trying to make a post request to the Kong gateway with the path of /echo, and I'm going to pass some body in JSON format to my request. So if I hit send, I switch to the terminal. In here I see that the request has been received by the Kong API gateway, which is a post request, and the HTTP log plugin has successfully sent relevant data to the Node.js server, and it has been logged to the output of Node.js server. So in here we can see all the data has been included to the HTTP request of the HTTP log plugin. So we can see like the method was post, the size, the URL, and all the other data that has been sent by the HTTP request plugin. So this is basically how this plugin works. In the Node.js server, as you can see, we can get the data, we can store it in a database or a file, and like for example we can do analysis on that. We can set alerts, so if we detect any anomalies we can have notifications sent to us, or any other stuff that we can do depending on our case.
So as you can see, I am in the official Kong HQ documentation page for the correlation ID plugin. As it is stated over here, this plugin correlates requests and response using a unique ID transmitted over an HTTP header. So basically what it does is that it adds a unique ID for every request as an HTTP header that passes through the Kong API gateway. So this plugin is totally compatible with DBLS mode, which is the mode that we are trying to use in this video series. So I'll scroll down, and in the enable globally tab and in the declarative YAML tab over here, I can find a very basic sample that I can copy paste to my configuration file, give it a try to see what it really does to our requests. So I'll copy this, I'll switch to the VS Code over here. As you can see in my repository, where I'll put all the files and configurations and everything that I create in my videos, I have the Kong directory in which I've created a 2023 directory, and In here I have a config directory plus a docker compose file, and in the config directory I've got only one kong.yaml file, which is the exact setup for the previous videos. So if we go to the docker compose file, this is the exact same docker compose file in the previous videos, which has only got one service using the Kong latest image and only one volume that is exactly the same ./config directory mapped inside the container in a directory where in the environment variable section I've passed a Kong declarative config and passed in exactly the same directory with the file name that exists inside the ./config directory. And there are some other environment variables and also some ports that are mapped to this container, so I'll be able to access this through the outside network of this container. So if you want to learn more about these configurations and how to initially set up the Kong API gateway in Docker environment, I've got the very first video of this video series where I'll put the link down below, so if you want you can check it out. And next I'll go to the kong.yaml, which is the file that is mapped inside the container where it holds all the configurations for the Kong API gateway. So as always I've got an echo server running on a random port. If I go to this URL in the browser, as you can see it just echoes whatever request that it receives to the output. So going back to the official documentation, I'll just try to copy paste this sample that is over here, and in my plugins section I'll paste it. So as we can see, the name of the plugin is provided over here, which is correlation ID, and the config for this is the header name, generator, and echo downstream. So going back to the documentation, here we can see all the available parameters that we can pass to this plugin. So as we saw, the name, which is the correlation ID in order to use this plugin, and we've got things like header name over here, which is the HTTP header name to use for the correlation ID. So basically by passing the value for this key, we will be able to define the custom header name that we want the correlation ID to be as its value. Next, we've got the generator, which is the generator to use for the correlation ID. The values can be UUID, UUID plus counter, and the tracker. So if I click on the generators over here, the UUID generator will generate something like this. The UUID plus counter will generate the exact same thing plus a counter at the end. So as it is stated over here, this format will generate a single UUID per worker, and it will append a counter to the UUID after a hash sign character. Or next we have the tracker format, which will create something like this, which is the combination of IP, port, PID, the connection, and the connection request timestamp. So we're going to see all these in a short moment. So with this sample configuration, I'm just going to bring up my Kong API gateway so we'll be able to see this in action. So I'll save this file, go to the terminal, I'll hit ls to make sure I'm in the exact same location where the docker compose file exists. The only thing, I'll say docker compose up -d, and this will try to create a container and a network and attach that container to that network, exposing the defined ports to the outside network also. So if I say docker compose logs, I'll be able to see the logs of the container that is created by this docker compose file, and as I'm seeing over here, things looking good. I'll just go to the browser and make requests on port 8000 and /echo. So I'll basically add /echo because I've passed the /echo over here, which will route the request to the echo server's IPN port. So if I hit enter, as you can see, I'm getting the response from the upstream server, which is the echo server, and also I've got the Kong request ID header at the end. So the first thing, I'll try to change this, and as its value we can see that we've got a UUID over here and the counter over here separated by a hash sign. So if I hit refresh, as you can see, for every request the counter is adding up by 1. So next I'm going to make some changes in the plugin configuration. So I'll remove the Kong dash from the header name in order to make some changes to see if it really applies to the header name, and also I'll try to change this generator to the tracker, and also we've got the echo downstream configuration over here, and as it is stated in the documentation, it is a boolean typed key which defines whether to echo the header back to the downstream or not. So basically the downstream will be the client that is making the request. So by default it is false, and I'm going to leave it as it is. So I'll save this file, go to the terminal, hit Ctrl+C and restart my container. Again, go back to the browser, localhost port 8000/echo, and if I hit refresh, as you can see, the header name has changed to only the request ID, and as the value for the correlation ID, I've got the IP address, port 8000, the process ID, and the connection, and the request timestamp. So as you can see, I'm in the official documentation page of the Prometheus plugin in Kong API Gateway. So as it is also stated over here, this plugin will expose metrics related to Kong and proxied upstream services, which can be scraped by a Prometheus server. And also this plugin is totally compatible with the DBless mode, which is the mode that we'll actually try to implement in this video series. So I'll scroll down in the Enable Globally tab, and declarative mode, which is the same as the DBless mode. So this is the very basic sample in order to make use of this plugin. So if I scroll down over here, I've got the available parameters that I can pass to this plugin. So I've got things like status code metrics, which is a boolean typed key, and this will enable the Prometheus plugin to also export the status code metrics, so it will be collected by the Prometheus server. It will add keys like HTTP requests total and stream sessions total. So I think we just go ahead and copy this very basic sample over here. So I'll copy this, go to the configuration file, and in the plugins section I'll try to paste it over here, and as the example parameter and example value, I'll just go ahead and copy the status code metrics, and I'll pass true as the value. I'll save this, and if I switch to the terminal in the exact same location where I've got the Docker Compose file, I'll try to say docker compose up-d. So if you don't know how to set up Kong API Gateway in DBless or declarative mode in Docker environment, I've got the very first video in this video series where I'll put the link down below, so you'll be able to access it easily. And if you already watched the video, let's move on. So I'll hit Docker Compose logs to see the output of the logs that are created by this Docker Compose file, and as I can see, things looking good. So I'll switch to the browser, and in here I'll hit localhost port 8001/metrics. I'll hit enter, and as you can see, this is the Prometheus format of the metrics that are exported in Prometheus format. So the Prometheus server will be able to collect these data in defined intervals from this Kong API gateway node. So just keep in mind that this plugin will collect the metrics of this instance that is running on this machine. If you have a cluster of Kong API gateway running on different nodes, then each instance will export its own metrics, so the Prometheus server will have to collect the metrics from each node. So as we can see in the metrics page, because I have enabled the stats code metrics, I should be able to see the HTTP request total metrics also exported over here. So if I try to find it, as you can see, there is no metrics exported with this name. So I'll try to make a request to the localhost port 8000/echo. I'll hit refresh many times, and if I also try to refresh this page, you can see some metrics are added over here. If I try to find this, you can see that these metrics are also exported from the Prometheus plugin. So again, if I hit refresh over here, as you can see, the value was 5, and if I hit refresh, the value gets added for every time that I hit the refresh button. So going back to the documentation, we've got other parameters like latency metrics, bandwidth metrics, upstream health metrics, which I'm going to add to the configuration file. So I'll copy this, add it over here, give the true value. Also the same for the bandwidth metrics, I'll pass the true as the value, and also for the upstream health metrics, and again true as the value. As we can see, the default value for these are false. So I'll go back to the terminal, hit Ctrl C, restart my container, and again go to the metrics page, hit refresh, and also go to the /echo, hit refresh many times, and go back to the /metrics, hit refresh again. As we saw, the stats code metrics that are added over here. Also the latency metrics should be over here. So these are the exported data that are related to the Kong latency in milliseconds. And also we should have the metrics for the bandwidth bytes that are passed through the Kong API gateway. So these are the values for these keys. And that's it for the Prometheus plugin in Kong API gateway. So in an upcoming video, we'll be seeing how to configure a Prometheus server to come and collect the metrics data from the Kong API gateway, and also we'll see a Grafana dashboard in which we'll be able to monitor the exported and collected data in an overview of a dashboard. So as the basic setup of Kong API Gateway, as always we have an API client which makes the request through a route to our defined services to Kong Gateway, and the service will route the request to the backend services, which also known as our upstream servers, and gets the response from those backend services and routes back the response to the API client that made the request. So if we want to implement a load balancer, we should have a load balancer sitting between the service and our backend services. So the client will make the request through a route to our services, and using the load balancer, the request would be distributed between our backend services. So this functionality will add to our system's high availability and reliability also, and it is one of the best practices to have in our production level applications. So as I said, an upstream object refers to our upstream API services sitting behind Kong Gateway, to which the client requests are forwarded.
In Kong Gateway, an upstream object represents a virtual host name and can be used to health check, circuit break, and load balance incoming requests over multiple services. So supposing that we know the basics of load balancing and we know why we need it, we're going to proceed to implementing the load balancer using the Kong Gateway. And also I recommend you watch the load balancing implementation using Node.js to find out the basics and have a total overview of what load balancing is, which of course I'll put the link down below. So diving into the implementation section, as always I have an echo server running in a random port which echoes whatever request that I make to it, and also another one in another defined port. So I have two echo servers, each running in a defined port and echoing whatever request with any data that are sent to them. So moving to the configuration for implementing the load balancer, I'll switch to the terminal, and also I recommend you clone my repository, which I'll put the links down below to have all the configuration and codes that are written in my videos. So in here, if I hit ls in the Kong directory of my repository, here I have my configuration file and my Docker Compose file, which I'll use to run the Kong API gateway. So if I nano Docker Compose file, in here I have my base image, which is the official Kong latest image, and the volume that is mounted inside the container, which is the ./config directory, which holds my configuration for the declarative mode of Kong API gateway. Also, I have some environment variables, which for example turns off the database mode, the declarative configuration file, and some other environment variables. And also in the ports section, we have some ports exposed to the outside world, by which we'll use to reach to our Kong API gateway. So I'll exit the Docker Compose file, and also we have the configuration file in the config Kong YAML, which holds all the data that we define to the Kong gateway, like for example our services, our routes, our plugins, and also in this video our upstream servers. So if you want to learn more about how to installing and deploying Kong Gateway in Docker environment, and also using the available plugins for Kong API Gateway, I have a whole playlist, which also I'll put the link and you can access them so easily. But if you already know about the configuration file of Kong API Gateway, in here we can add our configuration and pass it to the Kong Gateway in Docker environment. So as we can see, we have three main parts, which is the services and upstreams and the plugins. So for the upstream section, we have an example which targets our own IP with the port of the first echo server, and the other with the same IP and the other port for the second echo server that is running in my machine. And for the plugins section, we have a simple rate limiting plugin which limits the user requests limited to 50 per minute. So of course I explained all about these plugins in my playlist, so just go check them. And moving to the services section, in here we have an example service which has the host of the example upstream with the exact name that we defined in the upstream section, and also in the routes section it has a path with the /test. So we successfully defined our upstream targets, we passed it to our service, and also we defined our service and passed our upstream to the service. So the service knows its upstream server, which will route the request to it, and the upstream knows about its targets and will load balance between the targets that are passed in here in the configuration file. So I'll exit the nano. In here, as you know, all I need is a Docker Compose up. So this will run my Kong gateway in the port that we defined in the Docker Compose file, which is 8000. So if I go to Chrome, I'll try to reach the 8000/test, which I define the relevant service in the configuration file, and as the response I can see that I get the response of one of the echo servers. So now I don't know which echo server I'm getting the response from. So to show you this, I have two terminals, and in each one I'll try to reach the logs for each of the echo servers. So I'll say docker logs -f to follow the logs and the first echo server, and in the others again I'll say docker logs -f the second echo server. So I'll try to make some requests. If I hit refresh, I see that the response is coming from the first instance. Again, I'll hit refresh. The request routed to the second instance. Again, if I keep refreshing, I see that the load balancer is distributing the request between the upstream servers. So I'm sure you already noticed that the one of the instance is getting more requests than the other. So the reason for that, if we go to the configuration file, and here I'll hit Ctrl+C to stop the conf gateway. I'll hit nano config conf YAML, and in here we see a configuration by the name of wait. And for the first instance it is 100, and for the second instance it is 50. So the chance the request would be routed to the second instance is half less than the first instance. So if I want my request to be routed equally to each echo server, I'll just pass 100 to the second instance also. So I'll hit save, and again docker compose up. Again, I'll hit some enters to move up the previous logs. Again, in my browser, if I hit refresh, the request coming from the first instance, the second request routed to the second instance. So this way they have equal chances the request would be routed to. So again, I'll hit refresh. You'll see that the requests are routing to each of the echo servers equally.
So as you can see over here, I'm in the official documentation page for the response transformer plugin in Kong documentation website. So as we can see over here, this plugin will transform the response sent by the upstream server on the fly before returning the response to the client. So basically, things that we can do with this plugin is that we can add additional headers or data to the body. We can append them, or we can remove some static headers or body data and stuff like that. So going further in this documentation page, we can see the order of the execution of the functions that we can implement with this plugin. So basically, this plugin will initially try to remove the things that we declared to this, like for example our backend services have some data in their response body and we want to remove them before sending them to the client, and actually we do not want to make any changes in our backend services. So actually we can do this with configuring the remove section in the conf.yaml file. So next, the plugin will try to rename the things that we declare. Next function, it will try to replace and then add and then append the data that we define in the configuration file. So actually we're going to implement this in the dbless mode or the declarative mode of Kong API Gateway. So as the basic example, we can see over here, we can define the plugin's name and the scale that we want this plugin to be applied to, and right over here we have the configuration section that we can configure based on the available parameters. So I'll move to the configuration reference. Over here we can see the available parameters that we can pass to this plugin. So basically we can define things like the name of the plugin, which is a required field. So basically we should set this to the response transformer, and actually don't mix this plugin with the response transformer -advanced, and actually it has got some advanced configurations that is only available in the paid version. So next configurations, we have things like the service name or the service ID in order to apply this plugin to a specified service, and we've got exactly the same configurations for the route and the consumer and also the consumer group. So basically the enabled field will actually turn this plugin on and off, which is by default set to true, and you can set it to false if you want to disable it temporarily. So the main thing on the configuration section right over here, we've got the exact same functions that we saw in the execution order section. So we have the remove, rename, replace, add, and append. And actually we're going to see some examples in the instance that we're going to set up in a moment as a Docker container. So I'm going to move to the VS Code over here, where I've got my Docker Compose file and the kong.yaml file in my GitHub repository in the Kong directory, for which you can find the link down in the description section of this video, where I put all the files and configurations and any other stuff that I create in my videos. So right over here in the Docker Compose file, you can see that I've got two services. One I've called the backend service, which uses an echo server. So basically it will echo whatever request that it receives back to the client. So this is just a dummy service that we'll use to see the behavior of the plugin that we're going to enable shortly. And right over here, we've got the Kong service, which uses the Kong official image, and it has a volume mounted to inside it, which is the // directory that is located right next to the Docker Compose file to this exact directory inside the container, and which is actually the exact directory that I've defined on the environment variables section to use as the configuration file in the Kong service that will be up and running inside the container. So in this environment variable section, we've got other configurations, like for example, I'm trying to turn off the database, redirect all the logs to the std out, and all the error logs to the std error. So basically, as a result, I'll be seeing the output of any logs or errors on the container logs that I can simply access by saying docker logs. So we've got some other environment variables that we're not worrying in this video. On the port section, I've got some ports mapped to the outside, especially port 8000, which actually I'll use in order to access the Kong server. So next, right over here on the kong.yaml file, I have defined a service and I've called it echo server, which is actually a service proxy to the URL of backend, which is exactly the same name as I defined in the Docker Compose file. So basically, because these two containers will be created by this Docker Compose file, they will actually be sharing the same Docker network, and actually they can see each other through their service names. So basically, if you are running your backend services separately from this Docker Compose file, you should actually define your IP address or the domain name for your exact backend service. So supposing I'm running my backend service on 10.10.100 on port 8000. So basically I should define it with this exact URL over here. So actually I'm not going to do this and uncomment this. So as a result, I'll have a proxy to the echo server that will be running also as a Docker container. So on the route section, I've got a path that is /echo, which will then be the exact same path that I'll use to make requests to this service. So right over here on the plugins section, I've got only one plugin, that is the response transformer plugin, and because I haven't set any route or service or consumer and any other stuff, this is actually going to be enabled globally and will actually apply to any consumer or any service or any other stuff that I define in my configuration file. So on the config section, you can see that I've got a remove configuration that actually removes the headers with the name X to remove. So basically, if the echo server sending back the response to the client has any headers with this exact same name, actually this plugin will remove it, and as a result the client won't see this exact header on the response that it receives. Also right over here, I've got a JSON configuration, which is exactly the configuration that we'll use in order to remove some data from the response body. So basically, I'm going to actually comment these so we can see in the response body that these two fields exist, and later I'll try to uncomment this so we can actually see that the plugin is removing these two fields from the response body. So with exact same configurations, we can use the add directive in order to add some headers with key value pairs as an array, and over here we can use JSON as we saw in the remove section in order to add some key value pairs to the response body. So actually the point is that with defining the JSON underline types, we actually define the types of the values that the transformer plugin will actually try to cast the values of these key value pairs. Also quite the same thing for the append directive. I've actually used it to append some more headers to the response that will be sent back to the client. So I'll hit save, and if I move to the terminal, let me just make this a little bigger, and if I hit ls, you can see that I'm in the exact same directory that I've got my docker compose file and config directory. So if I hit docker compose up-d, I'm actually expecting my both containers to be created along with a network attaching to those newly created containers. So basically, as I mentioned before, the network will be shared among these two containers, and as a result they can see each other through their service names. So if I say docker compose ps, I should actually be seeing the op status for both the containers, and right over here I can see the exact ports that I've mapped to inside the container, and as a result I'll be actually able to make requests to the Kong server. So right now I'm ready to make requests and actually see the behavior of the response transformer plugin. So in order to make requests, I'll actually go to the browser. I'll try to go to my laptop's IP address on port 8000, and if I hit enter, as a result I should see an error saying that no route matched with the given values. So if I hit /echo at the end, I should see the response coming back from the echo server that is also running with the exact same docker compose file. If I go to the inspect on the network tab, I'll hit F5 to make another request, and if I inspect this request over here on the response headers, I can see two H1 headers, H2 headers, and some other headers that I configured in the Kong configuration file. So if I go back to the configuration file, you can see that these three headers are being appended, as we can see right over here, and also the H1 and H2 headers are being set right over here. And on the response body, if I go to the previous section right over here, I can see that I've got the key value pairs that I set on the add section. So I can see the boolean set to false, number set to 1 to 3, and string set to some random string. So these are exactly the same things that I've set on the configuration file. So right over here we can see we've got the host HTTP request keys that are being returned from the echo server. So like for example, I don't want this host and HTTP keys to exist in the response body that is sent back to the client. So in order to remove them, I'll go back to the configuration over here. I'll try to uncomment these and change the request to HTTP. So basically on the remove section using JSON, I am trying to remove the host and HTTP from the response body that is sent back to the client. So if I go back to the terminal, I'll say docker compose down and docker compose up-d again, and I am expecting my new configurations to be applied with the new container that will be up and running. So I'll hit docker compose logs -f to follow and --tail 100 to grab the latest 100 logs, and as a result I can see things looking normal. And if I go back to the browser over here, I'll try to remove the existing logs, and if I hit refresh and again try to inspect this record over here on the previous section, I can see that the both host and the HTTP keys are removed from the response body. So in a total overview over here, I've got a schematic that shows the Kong API gateway standing between the client and the upstream servers, which are actually our backend services. So basically the request will be first received by the Kong API gateway, and then the request transformer plugin will actually try to make some changes to the request before actually proxying it to the upstream servers. So basically it can do things like adding headers, removing query strings, or stuff like that, which we're going to see in details in a moment. So if I go to the official documentation page for the Kong API gateway on the request transformer plugin section, so again it is stated over here that the request transformer plugin allows simple transformation of the requests before they reach to the upstream servers. So actually don't mix this plugin with the request transformer advanced plugin, which is actually the advanced version of this plugin, which actually has a lot more features, and it is only available on the paid version. So that's not what we're going to cover in this video. And next, right over here, I'll go to the configuration reference section, in which we can see all the available parameters that we can pass configuring this plugin. So basically we're going to actually deploy this plugin in a declarative mode, and we'll actually use some of these parameters in order to demonstrate how this plugin works in action. So as always, we've got the name parameter, which is a required field, which in this case we're going to set to the request transformer. And next over here we've got the instance name, the service, route, consumer, and consumer group, by which we can set the scale of this plugin. So basically it will be applied to one of the scales that we configure in the Kong configuration file. So if we do not set any of these fields, the plugin will actually be enabled globally and will be applied to all the services, routes, and everything else. So we've got the enabled field, which actually enables and disables this plugin. So it is by default set to true, and we can set it to false in order to temporarily disable this plugin. And right over here we've got the config field, which will actually use to change the data on the request that is received by the Kong gateway and will eventually be proxied to the upstream server. So we've got the HTTP method, by which we can set the method of the request for this plugin to be applied to. Like for example, we can set it to get, post, put, or delete. And next over here on the remove section, we can actually remove some data from the request's body, headers, or the query strings, and it is quite almost the same for the other configurations. So in order to give a test to this plugin and see in action how it works, I'm going to actually switch to the VS Code over here, where I've got a Docker Compose file and a Kong.yaml file in the Kong directory in my GitHub repository, where I put all the files and configurations, and you can find the link down in the description section. So as you can see over here, I've got two services. One I have named the backend service, which actually is an echo server and basically returns the detail of the request that it actually received. So basically this is a great example to see what data has been sent to the upstream server. And next right over here I've got the Kong service, which uses the Kong official image with the latest tag and a value mounted inside it, which is the ./config directory to this exact directory over here. And actually on the environment variable section, I have set the database mode to off. That's because I'm going to configure the Kong gateway using a configuration file. And right over here, by using this environment variable, I am actually defining the Kong.yaml, which is my configuration file, in which we're actually going to configure our upstream servers and the plugins, which we'll see in a moment, and some other environment variables that we're not worrying in this video. So on the port section, I've got a port which is 8000 mapped to exactly the same inside the container. So basically it is the exact port that the Kong service will be up and running inside the container, and by mapping this port I'll be actually able to make requests from my laptop to the Kong server inside the container. So next I'll move to the Kong.yaml file. Right over here you can see that I've defined a service and I've set the name to the echo server and set the URL to the backend, which is exactly the service name of the echo server that we have right over here. So basically, because these two containers will be up and running using the same Docker Compose file, they'll actually share the same Docker network among each other and can actually call and see each other through their service names. So in your example, if you don't have your upstream server in the same Docker Compose file, you will actually have to change this value and set it to something like http 10.10.10.100 and maybe on port 8080. So basically this service will be a proxy to this IP address on this very port over here. Or actually, if you have your upstream server exposed with a domain name, you can also set this value to the relevant domain name right over here. So I'm going to remove this because by defining backend on port 80, which actually I won't define, so the request will be proxied to the echo server that will be up and running alongside with this Kong gateway. So on the route section, I've defined a route and set the path to /echo, and which is exactly the same path that I'll use to make requests to this service. So finally, right over here on the plugin section, I've got only one plugin that I've set the name to the request-transformer. So by doing this, I'm actually enabling the request transformer plugin, and actually because I haven't set any service, consumer, or any route or anything else, this will actually be enabled globally and will be actually applied to anything that I define in my kong.yaml file. So right over here on the config section, I've configured two of the functions that this plugin actually can do. One, I've configured the remove, and inside this I've defined a header and a query string to be removed from the request that the client will make. And actually, if the request includes this header or this query string, the proxy request to the upstream server won't actually include these two fields. So on the other hand, with the add directive, I've tried to actually add a header and also a query string to the request. So despite the request of the client will not include this header or this query string, on the response of the echo server, we'll actually see that these two fields also are included in the request that is received by the upstream server. So if I hit save, I'm ready to actually spin up my Kong API gateway. So I'll move to the terminal, and right over here, I'll hit ls to make sure I'm in the exact same directory that I've got my Docker Compose file, along with the config directory that holds the kong.yaml file. So right over here, if I say Docker Compose up-d to run this in detached mode, you can see that a network has been created along with two containers sharing the newly created network. So if I say Docker Compose ps, I should actually see my both containers with the state up, and right over here I can see exactly the same ports that I've mapped to the Kong container. So by hitting Docker Compose logs -f to follow the logs, and --tail 100 to grab the latest 100 lines of the container logs. So over here I can see things are looking normal, and I should actually be able to make requests to this Kong instance. So I'll move to another terminal, and right over here I'll try to paste a curl command that actually sets two headers. So actually one of the header names are exactly the same thing that I've configured in the Kong configuration file to remove this header before proxying the request to the echo server. Also on the query parameters section, I've got two query parameters, one exactly the same name, again I've configured in the Kong YAML file to remove that query string before proxying it to the upstream server. So if I hit enter, and I can see a JSON which I'm going to actually copy and paste it over here on the VS Code, and I'll actually try to format this so we can actually see the exact key value pairs. So right over here on the query section, you can see that a new query parameter has been added because we have set the exact same thing on the add section of the conc.yaml file, and also we've got the other query parameter that we sent in the URL of the curl command. Also, we can verify that the to remove query parameter has been removed from the request that is proxy to the upstream server. So actually these are the query parameters that are received by the echo server, and we can see that it doesn't include the other query parameters that we configured in the conc YAML file to remove before sending it to the upstream server. So exactly the same we can see in the header section, that we have the new header added to the headers, also because we try to add it over here, and also we have the header that we sent using the curl command, but actually we do not have the X to remove header because again we set the remove configuration in the YAML file to remove the exact header with this exact name. So that's all for this video. I hope you'll learn something new in this one, and if you have any questions, any recommendations, you can go ahead and ask me in the comment section down below. So of course there are more to learn about the Conc API gateway in order to actually customize it based on your use cases and your resources. So I highly recommend you read through the official documentations, which you can find the link also in the description section of this video. So if you like the content, please don't forget to hit the like button and subscribe to my channel, which will greatly motivate me and help grow the channel, and hopefully more people can learn things out of this channel. So lastly, don't forget to give a visit to my channel where you can find videos about other cool technologies. And with that, that's all for this video, and I hope to see you in the next video.